In this unit, we're going to look at exponential applications and how to write exponential functions, both with a given base and problems with percentages. So in this video, we're going to look at how to write exponential functions with a given base. So exponential word problems with a given base are going to be scenarios where we are doubling or tripling or halving, and we're going to be looking for keywords that actually give us the base in the problem. Okay, so this is on your formula sheet, the y equals a times b to the x power, and we're going to look at today different ways that this will look using different notations, different variables, but this is the formula that will be given to you. So we know that y is the output and can also be written in function notation. So we might also see this as f of x equals and then ab to the x power. A represents the y-intercept, which in a word problem is the initial value or the starting value. Now we need to be careful with this vocabulary word right here, because if we think about on a graph, the y-intercept is when the x value is 0. That's going to be really important. So the initial value has to start at 0. B represents the base, which we've talked about a lot already in this unit. And again, these are going to be problems today where we have a given base. So if it says that it is a scenario where it's doubling, then the base would be 2. If it's tripling, then the base would be 3. So it's going to give us the base either in words. It could be a table where we have to try to figure out what the pattern is, or it could be a graph where, again, we would need to identify the pattern. This is going to be a really helpful tool for us as we move into these problems if I can't find the base. So I know that maybe it's growing exponentially. I can tell the numbers are getting bigger rapidly, but are they doubling? Are they tripling? I'm not sure. So to find the base, you can take any output, any y value, and divide it by the preceding y value. So y2 divided by y1, and that will give you the base. So let's look at an example. Example 1, since 2002, John has been holding an annual 5K run to raise money for the Cystic Fibrosis Foundation. In 2002, there were 10 people who signed up for the run. Each year, the number of participants has doubled. Write a function c of x to represent the number of participants after x years. So since we're looking at since 2002, 2002 is my initial value. This is my starting number. So we started with 10 people. If I were to graph this, my y-intercept would be 10. Okay, so A is equal to 10. The base is going to be your multiplier. So what's happening with the number of participants? Each year they are doubling. So each year we are multiplying the number of participants by 2. So it gives us the notation that it wants us to write the function in. So we would write c of x equals, and then the formula, again, you'll have this formula is ab to the x power. So sometimes the way that you'll see it is 10. Now I can't just write a 2 next to it, or it would look like 102. So for multiplication in math, we can put parentheses, so 10 times 2, and then to the x power. Or sometimes you might see it just with a multiplication symbol. So we could also write 10 times 2 and then to the x power. Either way is acceptable, and in a multiple choice question, on the milestone, on our Illuminate assessments, you could see it either way. Example 2, Mrs. McAllister bought 4,096 pencils at the beginning of the school year, and each month she loses a fourth of her pencils. Write a model P of M to represent the number of pencils after M months. A model is the same thing as a function. So it's asking me to write a function as P of M equals. So we need to find the value of A, which is my initial value, which in this case is 4,096. Then my base, which is the multiplier. So what are my pencils being multiplied by each month? If she's losing a fourth of the pencils, then the base would be 1/4, and then to the x power. So an important thing, I'm going to go ahead and talk about it. We're going to see it a lot more, but in a situation where the scenario is showing decay or depreciation, or it's going down, it's decreasing, your base is going to be a number in between 0 and 1. It will never be a negative number, okay? So it might be a half or a third or an eighth or a 16th even. Those numbers are all smaller than 1 but bigger than 0. Any base greater than 1 is going to be an increasing scenario. Example 3, the flu has been quickly spreading this year. The first case was reported in November, and each week the number of people with flu has doubled. Write a function f of w to represent the cases of the flu after w weeks. So we would write this as f of w equals. Now, what's the initial value? I do see that the flu is doubling, so that means that my multiplier is 2. So my base is going to be 2. But does it give me an initial value? Well, it says the first case was reported in November. So how many cases did it start with? It started with just 1. Now, if your A value is 1, so this is telling me that my initial value is 1 person. The 1 is the coefficient, so we would not need to write it. So we can put this in parentheses and do 2. Now we need to be careful, and this was incorrect on the last example, but whatever it says that your input is, that needs to be the same as your variable or your input variable. So instead of using an x, this is telling me that my input needs to be w. So we would write 2 to the w power. Now we could also write this without parentheses since it's only being multiplied by 1 and just write it as 2 to the w power. Example 4, we're looking at a graph. So the graph below represents the number of laps Melissa is swimming each day to prepare for an upcoming triathlon. Write a function L of x. So we are going to write L of x equals the number of laps that Melissa swam after X days. So I think that there's multiple ways to approach this problem, and some of you it's going to be easier visually to see what's going on than others. I would recommend making a table. So we can see on the x-axis that our first point is at 1, and then I have a point at 2, 3, 4, and 5. So going backwards, at 5, she swam 80 laps. After 4 days, she swam 40 laps. After 3 days, she swam 20 laps. So again, I'm just looking at these on the graph. After 2 days, she swam 10 laps. So after 1 day, it's in the middle here, which we can see is at 5. But if you weren't sure where it was at, you could use your pattern to find it. We also talked about in the beginning of this video, the trick to be able to find the base if we don't know it is to take any of your y values and divide the one before it. So y2 divided by y1. Now the order here matters. So you could start with 80, you would need to divide by 40. You could start with 40, but you would need to divide by 20. You could start with 20, but you would need to divide by 10. If you go the other way, it's going to look like it's decay versus growth, okay? So I can do 80 divided by 40, which gives me 2. So that tells me that the pattern here is multiplying by 2. So after 1 day, she would have swum 5 laps. Now, we need to be really careful when we're writing our equation. I know that the base is going to be 2. My input variable is x, so it will be 2 to the x power. But for my initial value, the initial value is not 5. The initial value is always going to be when x is 0 or my y-intercept. So in this case, I'm going to need to find it by working backwards. So if I know that the pattern is multiplying by 2, if I go backwards, then I would divide by 2. And 5 divided by 2 is 2.5. So that means that my A value is 2.5, and this would be my equation. Now again, as a reminder, we could also write this without the parentheses, and we could write 2.5 and then just times 2 to the x power. Kylie is selling candy bars to raise money for her chorus program. The graph below represents the candy bars she has remaining after each day. Write a function C of D to represent the number of candy bars that Kylie still has remaining after D days. Okay, so we are going to write this as C of D equals. Important to remember that my x-axis represents the D days. So instead of using the variable x, we are going to use the variable D when we're writing our function, okay? This one has a line on it because this is called continuous. So she's selling candy bars throughout the day, so it's decreasing throughout the day, but we are just collecting that data point at the end of each day, okay? So I do have my y-intercept in this case. My first point is at 0.81. Then after 1 day, they sold 20, or they had 27 remaining. After 2 days, 9 remaining. After 3 days, a little bit trickier to see, so we need to first figure out our pattern. So again, some of you guys might be able to see right off the bat that this is dividing by 3. Some of you might need to use our trick of taking any term, any y value, so we can use 27 and dividing it by the term before it. So we can do 27 divided by 81. Now, you're going to get a decimal when you do 27 divided by 81. If a problem, a scenario, a table, a graph is decreasing, then my base is going to represent decay, which means it will be a value less than 1, but greater than 0, okay? So we would need to change this to a fraction, and this would be 1/3. So that means that what's happening is we're multiplying by 1/3, which is the same thing as dividing by 3. So we could figure out if I take 9 divided by 3, that gives me 3. And we could keep going from there. Now, I don't need all that to write the function. A represents the initial value, or the y-intercept, which is 81. Then my base, which is 1/3. And then instead of to the x power, since we're using an input of D, this would be to the D power. And that's going to be my function. So example 6 is giving us a table. The table below shows the amount of money that Jason has accumulated after investing in a new company's stock in 2017. So it's giving me 4 different years of values. Now we can see that the stock is increasing. So that's really helpful. That tells me that the base needs to be something bigger than 1. So when I find my base, if it's less than 1, a decimal, or a fraction that's smaller than 1 but bigger than 0, that would be a red flag, okay? A table is nice too, and really the graph problems as well. we could actually check our answers with Desmos. We could take what we find for our function, type it into the Desmos graphing calculator, and either compare it to the graph or compare it to the table to make sure that the values are the same. Now on this problem, we have to be really, really careful because it tells us that he invested in the stock in 2017. So what that means is 2017 is my starting value, and that's going to be my y-intercept. That's the initial value in the problem. So when this table starts with 2018, that's actually when x is equal to 1. 2019 is when x is equal to 2, and so on. So I can figure out what my base is, but I don't have my initial value. That's why that's this first question. It's not $56.50. So in order to find the initial value, I would need to go backwards with my pattern, which means I need to find the pattern first. So we can use y2 divided by y1. So if I take 113 and divide by $56.50, that gives me 2. So that means that my base is 2. Now you could check it. If I multiply 113 by 2, I get 226. If I multiply 226 by 2, I get 452. So in order to go backwards and find your y-intercept, we would just need to divide by 2. So that gives me $28.25, which means that that is the initial amount that he invested into this account. So now we can write the function because I have the initial value. It's $28.25 and I have the base, and that's all we need to be able to write the function. So we can write j of x equals $28.25, and don't put a dollar symbol in here. You're writing the function. So when you are writing a function in math, an equation, you're not including the units. You would include units in your answer if you're like plugging something in or finding an output. And then my base, which is 2, and then this would be to the x power. So for our last example, it gives us a function, g of x equals 10 times 3 to the x power. This represents the average number of students attending Milton football games each year since 2006. Write a sentence to describe the meaning of this function. So what does the 10 mean and what does the 3 mean? What you should not be writing here is 10 is the initial value, or 10 is the y-intercept. 3 is the base. Those are important vocabulary words, but in this case, it's giving you a scenario and it wants you to fill those values in to the context of that situation. So in terms of Milton football games and students, what does the 10 represent? So because this started in 2006, that's our initial value. So in 2006, there was an average, because it does say the average number of students. So there was an average of 10 students attending games or attending football games. Okay, and then what does the 3 represent? The 3 is my multiplier or my base, so this is going to be growth. So since then, the amount has tripled each year. So important things is that you understand that the 3 means that it's tripling and you can put that into words, and that you understand that the 10 is the starting value for the number of students attending the games.